what is the meaning of capacitance or a capacitor? That capacitance comes from capacity. There is another answer from Ziyad that it is like the battery. Okay, I will consider it as battery also. You made the definition. Capacitance or the capacitor. Capacitance comes from the store charges. So capacitor is the device. Here told us it is
Sir, can I
device
check?
used to
Store
To store
electric.
store
charge.
Store
charge.
energy.
Store
Okay.
charges.
Have you ever seen this device? It can be like a battery, but it's not battery. Battery
Sir,
is
it's a
actually the
pill that.
storage that can be utilized for a long time, but this is not utilized for a long time. Yes, please.
Sir, does it look like a pill that has wires
Yeah,
coming
yeah,
out
yeah.
from both sides?
It is. It
Yeah.
is. It is like somehow black colored, blue colored. There are the
Yeah.
different color of this one, like the drum. Sometime like the plate. Sometime like the whole drum cylinder like thing. Sometime just like the plates. So these are different. We will see that their figures tomorrow. But I actually want to know: have you ever observed them in your daily life? Just give me this answer, and we will finish the class. We will continue tomorrow, day after tomorrow.
Yes, I have
Where you observe their effect?
on my motherboard in my PC.
Okay, what is their effect?
When the CPU needs more power, they can quickly give.
Sugar.
They
Sibo.
can give high voltage, but
I know. This is Hazim. That's why he is more accurate. You are actually 100%. What I want to know, actually, what happens when you switch on your laptop, your computer, your television? So it starts after some seconds, half a second or 1 second or 2 seconds, because the time you switch on to the time it gets started, it requires energy to store. So capacitors, that time they are storing energy. When you switch off them, or the light is just power is failure, your TV will not suddenly switch off. It will take some time and it will close the screen like this one. Why? Because the stored energy in the capacitor was being utilized for that time, during a power failure or during your switch off to that time, maybe 1 second or 2 seconds, or sometime you switch off your electric current, but still if you put your hand on the motherboard or on your circuit, you will get shock from there, because still there is a stored charge in the capacitor. Capacitors that might we use in our different circuits, these can be like this, I told you, like cylinders. These are like plates, a little beads, like seeds of are the grains of the different materials, like these beads are grains. So these are the different shapes of the capacitors. So what actually the capacitors are doing in different circuits? A capacitor, first of all, is a device that can store electric charge or that can hold electric charge, and sometimes are called condensers. We also use another name for them, condensers. So if someone is asking you condenser, so condenser is also a capacitor. So capacitor store charge for later use. How it uses the charge, like in flash cameras, we know we are not using the other camera, we are using digital cameras, but still they have a flash. So what happens, there are capacitors that are holding the charge. When you push the button, so the flash goes out because all the charge is just released. So when it released, so you get a boom like thing and the camera is flashed. Like the traffic signal cameras also using this capacitor thing. So energy backup device, we also use them as an energy backup device, like computers. If the power fails, so we can use that, but it doesn't mean that it is like a battery that you can use them for long time. No, it is for very short time storage. It will just help you not to shut down directly. You don't want your computer to shut down directly, so it will hold for a moment and you can quickly shut it down, and that time it will hold your computer and keep it on. Very tiny capacitors serve as the memory, as a one and zeros. You guys are very good in IT and you know what is that 1 0 thing. This is actually the binary code. It can be like on off, true false, these kind of conditions. So the binary codes 0 1 in random access memory of the computers, RAM and ROM, both things. So I told you I'm not good in IT, so I cannot explain you a lot. But I just know that there are two types of memories which I know, RAM and ROM, but it might be more than that. So very tiny capacitors are used for uh, memory of the binary codes. They keep the memory in binary of the binary codes. So capacitors use them. So this is just a general, you can say, overview about the capacitors, how they look like, and how they use are in different condition, how we use them. Now getting back to the point, generally we use a parallel plate capacitor that you can see in your figure A. Parallel plate capacitor are the capacitors that are usually used to store the charge. So I will explain you capacitor according to parallel plate capacitors, how they use. But before to start explaining equation and the construction of the capacitor, let me start with the symbols that we used for capacitor. Do anyone remember the symbols of the capacitor? How whenever you use in a circuit, so symbols are important because symbols help us to understand which equipment is there, which part of the circuit is now in function. So there are two symbols for the capacitor use. So this symbol that I am trying to make is actually because of the parallel plate capacitor that I am going to explain you. So this is first symbol. There is another symbol, like one thing is like this and other is like side is like this. So this is also the diagram or the symbol of the capacitor. So capacitor may be used whenever in a circuit. So there you can find this kind of symbol, and this symbol we also use in our physics study. But don't uh, compare it with this symbol. This symbol is not the
So, sir,
capacitor.
can you repeat about this sample?
Yes, there are two symbols used for the capacitors, the above two. This is the symbol of the capacitor, the first one and the second one. These two are the symbols of the capacitor. But this one, the third one, is the symbol for the battery. So don't mix the battery symbol uh, or the voltage source sample with the capacitor symbol. So you can if you are doing a symbolical representation, so you can draw only two lines here and here, so it will show you that this is a capacitor. So this is a capacitor, so it's a capacitor, it is also a capacitor, but the figure down, which has a positive and negative symbol, it is high voltage and low voltage symbol, so that is used for battery. So don't mix the battery symbol with the capacitor symbol. Okay, one thing is the symbol. Now what is the construction and how capacitor works? Let us discuss that thing. So working of the capacitor, how capacitor works. For the working, I'm going to discuss only parallel plate capacitor. I'm going to discuss parallel plate. There are many types of parallel plate capacitor. There is ring shaped capacitor. There is a rolled capacitor, spherical shape, plate capacitor. There are a lot of. So I am just going to talk about parallel plate now. Parallel plates capacitor. What is parallel plate capacitor? A parallel plate capacitor is a capacitor that has two oppositely charged plates, like you can see in this figure. This is the parallel plate capacitor. Here, this is one plate and this is another plate which is connected to the battery. So I will try to draw the figure for the parallel plate capacitor so I can show you like this. This is the shape of the parallel plate capacitor. This is a parallel plate capacitor that one end of the plate is joined with the positive terminal of the battery and the other end is joined to the negative terminal of the battery. So this is the plate A of the capacitor and this is plate B of the capacitor, which is connected to the battery. So this is the schematic diagram of the capacitor. So initially you know that there is a switch, always there is a switch between the batteries, and this switch is open. So when switch is open, you can say uh, no charge is stored, no charge stored when switch is open. Okay, open switch mean no charge because there is no current flowing through the circuit, so it will have no charge. When you close the switch, closed switch, what will happen? When you close the switch, the electron will start moving through this one. Okay, let me draw another figure, it's better, that will show you two different circuits. So this is switch is closed, then what happens? This is the parallel plates. Whenever you want to do something in hurry, you do mistakes. So this is a positive plate, potential difference. This is negative plate, potential difference V is applied, potential difference V is applied. When circuit is closed, when circuit is open, open switch or open circuit you can say, and this is closed switch or closed circuit. Now circuit is closed here. Potential difference is V. V is applied here, and this is plate A, and this is plate B. What happens when circuit is closed? Electrons starts flowing from this point. So first of all, electrons flow from negative end of the potential source, negative end to plate B. Okay, what will happen? Negative end to plate B, the electron will start flowing from here. What I was saying if when circuit is closed, if one electron starts and move toward plate B and collects at B, so because of electrostatic induction, because of
Electrostatic induction.
yes, what happens? Electrostatic induction, a force is being produced and a proton is attracted from the other plate. So proton of the other plate come close to the plate. It's like you are standing on a window and you are looking at the other window in front of your house. So someone will come and look at you. So this is the one interaction. So you are electron, the proton will come and it will look at you. So until you are standing on the window, proton is also on the window. Okay, now this is electrostatic induction. If there is no electron, there will not be a proton. Okay, what happened? Closed circuit is closed. So electrons are moving one by one from negative terminal to plate B. As the electrons are gathering, that much protons are being attracted by electrons. If there are 3 electrons, there will be 3 protons. And continuously, if the electrons are continuing toward plate A, the number of proton will also be same on the plate A. But keep it in your mind, if I use the word that there is q number of negative electrons, so there will be a q number of positive electrons on the plate A. Now these protons and electrons are attracted toward each other because of electrostatic force, because of electrostatic induction. So what happens when electrons are gathering? You can say that there is negative potential here. What is happening when electrons are gathering at plate A? So negative potential is there. So negative potential here, and proton are there, so it is positive potential here. So negative and positive potentials are in front of each other. So this potential will be how much? Because it is already some time spent, electron keep on moving, and now there is a potential difference created between plate A and plate B. What is potential difference? Plate A is at high potential, plate B is at low potential in equal amount. So there is a potential difference created. So this potential difference between plate A and plate A and B creates a potential difference equal to the potential difference of battery. How much? Potential difference equal to potential difference of applied voltage or battery. So what will happen? Now the flow of electron from negative terminal to plate B and proton from plate A will stop. Why stop? Because if this is you can say 5-volt battery, so there is a potential difference of 5 volt created here. So there is no change in potential. Nothing is at high potential, nothing at low potential. So the flow of electrons stops now. Now you can say that at this point, by applying potential V, a charge Q is being stored on the capacitor plates. Now, how much charge Q? Because I told you equal amount of electron and proton is created. So we will say that by applying potential V, charge Q is stored on it. Or you can also say that to store a charge equal to amount Q, you need to apply a potential difference V. If you increase the potential difference, the amount of charge stored will increase. So these are directly proportional. Mathematically, when proportionality is changed to equality, there is a constant always, and this constant here is C. So you will say that the equation of the capacitor will be Q is equal to CV, where Q is first of all stored charge on the capacitor plate, stored charge. V is potential difference across the plates, or you can also say potential difference applied, because I told you this is equal in amount, and this is the constant of proportionality, and it is called capacitance. It is called capacitance. So C is the capacitance, and if you want to know the capacitance, what you will do, capacitance is equal to Q over V, and its unit is farad, on the name of Michael Faraday. So it is on the name of Michael Faraday is SI unit. So if I want to define the farad, I will say 1 farad is capacitance of a capacitor when we apply 1 volt potential across plates and 1 coulomb charge is stored. Usually we have other units of the farad. Farad is a very big unit. So we use microfarad, nanofarad, and picofarad. And you guys are very well aware that 1 microfarad is equal to 10 to the power negative 6 farad. If it is nanofarad, so it is 10 to the power negative 9 farad. If it is picofarad, it is equal to 10 to the power negative 12 farad. Usually we use these small units of farad because farad is a bigger unit for storing the charge. Now, this capacitance depends upon what factors? So this C, capacitance of a capacitor depends upon what? Depends upon, number one is capacitance depends upon size of the plates. Size of the plates mean area. Area of the plates. How? If you have the bigger plates here in the figure, you can see if the plates are bigger, there will be more atoms. More atoms mean more electron and proton will gather and attract each other. So it's directly proportional. that capacitance is directly proportional to the area. So you can say that capacitance C is proportional to the area directly. Number two is distance or separation between between plates. So separation, let's say I ask the distance between them is d. So distance between the plates is d. So how it will depend? If there is very high area between the plates, there will be no electrostatic interaction, so no capacitance. So if the area is very small, there will be more capacitance. So more closer the plates, more capacitance. More farther the plates, less capacitance. It means the plate's distance is inversely related with the capacitance. So capacitance is inversely related to the distance of the plate. But the third thing which I'm going to tell is very, very, very important thing. What is that thing? It is material between the plates. Material between plates. Now, if you have some insulator material between them, let me write here word insulator, because if it is conductor, it means there is no separation. You understand this thing? If there are two plates like this, for example, I just try to draw. These are the plates of the capacitor. This is a positive plate A, this is negative plate B, and these are connected with the potential difference V volts. Now, the distance between the plates is, let's say, D, and area of the plates is, let's say, A, and there is a conductor between them. From here to here, you put a material like iron, like something. So where is the separation now? They are just connected to each other. So this is just a normal conductor, and they will start flowing the current. So we don't need conductor material, we need an insulator. If insulator is between them, then their capacitance will increase. If there is no insulator, then we will say, in normal circumstances, these are the two plates and there is only air between them. When there is only air between them, they have a specific capacitance depending upon that air. And air medium, you remember last time we defined, if there is air between the medium, we call that it has a particular value that is called permittivity of free space. And you know, we represent permittivity of free space as epsilon naught. So what you will do, permittivity of free space is epsilon naught. So you can say that capacitance is directly proportional to epsilon naught. But if there is a material, but if there is insulator between the material, insulator mean at this condition, like there is insulator between the plates. So what happens? The capacitance will increase. This is very interesting fact because of the polarization. I'm not explaining polarization, that there are more atoms now close to the negative plate, so more charge will be stored. So capacitance is directly proportional to the permittivity of free space, and also capacitance is directly proportional to permittivity of the material. This epsilon r, this is called permittivity of the material. So every material has insulator, I'm talking about and repeating again and again. Permittivity of material, sorry, permittivity of insulator material. So it will be provided to you. We call it relative permittivity. Epsilon r mean relative permittivity of the material, relative permittivity. So what we found, that whenever you are talking about the capacitance of a capacitor depends upon the area directly, the distance inversely, and the medium between the plates directly. What does it mean? If you don't have any medium, then you will say the capacitance is like this one. Let me show here. If no medium between the plates, if no medium between the plates, it means there is only space between them. If no medium between the plates, so you can say capacitance is equal to epsilon naught A over D. I told you inversely proportional to D and directly proportional to A, directly proportional to this. And if some insulator, if insulator is between, insulator present, insulator are medium, insulator present, you call it medium is between the plate. So when medium is between the plate, so capacitance will enhance, and the capacitance now will become epsilon naught epsilon r a over d. This relation we will not use a lot because we are not considering about the insulator medium. This insulator medium has a specific name. Insulator medium is also called insulator. We call it insulator between that or dielectric.
Excuse me, sir. Epsilon not represents what?
Epsilon r is relative permittivity. Relative
Okay.
permittivity is the permittivity depend upon the material. If iron is there, if sorry, not iron, if plastic is there, if water is there, if wood is there, everything has different value. So that's why we call it er, epsilon r. So this insulator material is called dielectric. We call it insulator is called dielectric. So if there is a dielectric between the capacitor plates, so stored capacity will increase. But this is this topic of dielectric is closed until here. We will not discuss. It is in our book. The next topic is about dielectric, but we are not going to take this year about dielectric. It means we are not going to take it. Not this year. We are not, because you are leaving the school after this year. So, but you just need to know one thing, that capacitance depend upon three things. First, area. More the area, more the capacity. Less the distance, more the capacity. Then dielectric is there, more the capacity. If dielectric is not there, then capacitance will be calculated by this formula. Let me write this formula as formula number 2. So this is the calculation of the capacitance when dielectric is not there, and this is the capacitance when dielectric is there. But we are going to solve a numerical without dielectric medium. So let us solve. We have a very less time, so that's why I'm running around. Before I start the numerical, there is a graph that is showing charge versus the voltage. This is the voltage which is charged. So which capacitor, A, B, or C, will have the greatest capacitance? Quickly, please. This is just a general knowledge question. You have three graphs
Is it A?
between voltage and Q. A, B, and C are the capacitors. Which is storing more charge? More charge, more capacity. So which one is it? Quickly answer, anybody.
A?
A. Why?
Because it
Because
has
it
the
is the
most
greatest.
capacity.
It is more straight, more steeper, so it is more. Yes, A is correct. But C mean less charge, more voltage, so it means it is not perfect. So less voltage, more charge is having more the capacity. So this is just a general knowledge question, that's why I'm not taking it seriously. Now getting back to the example, I have only 5 minutes, so I need you guys to hold the calculator. You know to whom I'm talking to everybody. Got it? Okay. First of all, calculate the capacitance of a parallel plate capacitor whose plates are 20 times 3 centimeter and are separated by 1 millimeter air gap. So you have to find capacitance. Capacitance is equal to, I just give you the formula, it is equal to epsilon naught A over D. I just forgot to tell epsilon naught is permittivity of free space. In Coulomb's law, we found that 8.85 into 10 to the power negative 12 Coulomb square per Newton meter square is the value. So please substitute the values. 8.85 into 10 to the power negative 12 times area is 20 centimeter. So 20 centimeter, let me make it meter directly. So it is 0.2 times 0.03 in square meter
Is it
over.
53.124?
Just give me 1 minute. You have already converted.
Yes.
Okay, 1 millimeter will become 0.001 meter. Am I right? 1 divided by 1000. What is the
Yes.
answer, please? Can you repeat? 53 point?
53.124 is what I got.
53.1. It is farad. Are you sure?
I
No,
got 53.5.31 times 10 to the power of negative 11.
that is correct. 5.31 times.
10 power negative 11.
Yes, because there is a 10 to the power negative 12. 5.31 into 10 to the
Oh
power
no, my
negative.
answer was in picofarads. I made the
Ah,
calculation.
okay, okay,
It
okay.
was
You
picofarads by
you
mistake.
you check the book. I know that.
Yes, yes.
Okay. So it is 10 to the power negative 11. To make it negative 12, I will multiply and divide by 10. When I will divide by 10, it will become 10 to the power negative 12, and multiplication will become 53.1. So 53.1 10 to the power negative 12 can also be written as 53 picofarad. So first answer is done in 2 minutes. Oh, you are
Sir,
very slow.
question.
Second, what is the
Do I
charge on
all,
the plate?
sir, question.
Yes, please.
Do I always have to keep it in the power of 12 pico?
No, you can write your answer in pico, nano, or micro,
So I
whatever
can't
you
keep
like.
it 10 to
But
the power
it
of
is
negative 11.
no, you can. But the capacitors are always having the value on written on them. Every capacitor will have be pico, nano, or micro. So it's better to write in all of these three units. If you will write negative 11, I will not do it wrong. It is correct, but still better to write the actual value. Now they are saying the battery is 12 volt. Find the charge across the plates. So this is the capacitance. We found it. Part B is they have given us the battery charge. V is equal to 12 volt. C is equal to 53.1 picofarad. Find the charge. What you will do, Q is equal to CV. Multiply your answer with 12 volt. So 53.1 into 10 to the power negative 12 time V is 12. What is your answer now? Quickly, please. How much charge will be stored? Quickly.
6.4 multiply 10 to the power negative 10.
6.4 10 to the power negative 10. So in nano, it will become 0.64.
Divided by 10, right?
Yes, 0.64 nanocoulomb.
It will be, yeah, 6.4 multiply 10 to the power negative 11.
Huh? Huh?
Wait,
Means
it said
what happened?
divided by 10, right?
Wait. What happened? Look here. This is negative 10 coulomb. So what I will do?
Sorry.
6.4 into 10 to the power negative 1 into 10 to the power negative 9 coulomb. Negative 9 coulomb is what? Nanocoulomb. And this is divided by 10. So it is 0.64 nanocoulomb. I was right.